You've probably heard of SQL injection and how dangerous it is to your apps. But do you know how it works? Knowing what SQL injection is and how to avoid it is critical to writing applications that are safe. Just because an application works doesn't mean it's safe. In this video, I'm going to show you how SQL injection works and how to make small changes to your application to prevent the most common SQL injection attacks. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning software development easier. I have over 800 videos here on YouTube, including 7 full courses to help you take your next step in your career for free. I also have paid courses on IamTimCorey.com. Those course funds go to fund my free content so that everyone can have a great education in C#, not just those who can afford it. So let's jump into this video on SQL injection. So I already have an application up and running. We're not going to build the whole thing today because that's just a waste of your time for this demo. Now, if you do want the source code for this, there's a link down in the description where it will send you an email with a link to download this source code. So the way this works is I have a database project. This is InjectableDB is the name I gave the database project, where I have 3 tables and 2 store procedures, as well as a means for publishing. You won't get the publish means. You have to do it yourself. But essentially what you do is you would right click and say publish, and then you would choose where to publish it to. I publish it to my MS SQL local DB, which is just a sample database for development on my machine. And then you say publish, and the result, you go to SQL Server Object Explorer, looks something like this, where you can see the tables. I've put some sample data in. The sample data does not come with the project, but really all it is if we view the data from the people table, you'll see that, and we'll view the data from the secrets table too. You'll see that in the people table, we have just 2 records, Tim Corey and Sue Storm. And over in the username and password, or the secrets database, we have 2 usernames and 2 passwords. Now, to be clear, this is a demonstration. This is not how you would build a real application. Please don't ever put passwords in a database in clear text. They should be protected. But this is kind of demonstrating this is what it might look like, or this is how it might work to get data from somewhere else. So we'll see how to use this in a minute, but that's just the basic setup for what we're going to do today, which is we're going to use this WPF application, which has a search box. We search, and then it gives us back our ID, first name and last name of any matching records. So let's just run this real quick to see it work. So I'm going to type in Corey as my search result because it searches last name. So I hit search and we get Tim Corey. And if I type Storm, then we get Sue Storm. So that's all that happens, right? That's the entire process. You might say, well, that looks great. So what's the problem? Because it works. And that's the most dangerous place to be as a developer, is to have an application that works. Because when it works, you think it's done. And you might even have a little bit of security on this. But this is kind of like, for me, if you've ever seen a house being built where it's framed out, and maybe they even put the front door on. And it's like locking the front door when the whole house is just framing, where you can walk into through any wall because there's nothing blocking you. That's kind of what a working application is like, where it might even have a doorway that may even be locked. But if the rest of the house is just open, you just walk in. That's what you have when you have an application that is not properly secured. And this application is not properly secured. So let's look at what happens. Now, I've put all of this inside the WPF project. Again, this is a demo application. I would move data access out and not tie it directly to my WPF UI, etc., etc. But let's look at the code behind, and in the code behind, we can minimize most of the stuff. We have the constructor. We have the basic setup for the placeholder. That's where it says like enter last name or something like that in that text box when there's nothing in there. And then we have the button click, the search button click, and if there is valid data in there, then we go ahead and search, and this is the actual search. Okay, so here's where our problem lies. And actually, this is demo code we don't need, so I'll get rid of it before you get access to it. So this is what we have right now, which is we're doing a select star from people where last name equals, and we're passing in the text in the text box. This is bad. This is bad. If you see this somewhere where you're taking text box text and putting it into a SQL query, stop it. Stop it right now. You have a problem. So we'll talk about why. So my basic adage is never trust the user. And right here, we're trusting the user to give us good data. What if the user said test 1, 2, 3, 4, 5? Well, it's going to search for test 1, 2, 3, 4, 5. Okay, that's not horrible, but there's other things they could give us that might cause us problems, and we're going to see those things soon. So, but this SQL statement, we're then using Dapper, but it does not matter. If you're using Entity Framework, this will be the same thing. You still got to be careful. So it doesn't matter what framework system, database type, doesn't really matter if you're doing it this way, because this is bad. So we're doing a query where we grab a person model as the results, and then we're displaying every person model in the search results. So that's all we're doing. So why is this bad? Well, we're taking text from that search box and putting it right into a query. So the query is going to look, let's just copy it, and we're going to create a new query window to see what it might look like. So you just right-click on your database and say new query. And then we can, in here, we'll just paste that query, and instead of putting the, this stuff right here, we're going to put Corey. Okay, that's essentially what gets replaced there. So if we run that, then we get, well, that's kind of small, but we see the results is record number 1, Tim Corey. Okay, that's what we're getting. But here's the problem. You can perform other commands on this in this query window. So for example, if instead of doing this, I wanted to say select star from secrets, and I ran that query, I would get back admin password and demo exclamation point. Okay, so I'd get back those two records. And you might say, well, yeah, but that's a separate query, Tim. That is true. But here's where, if you know a little bit of SQL, you can combine these two. So you could say something like this, where you say union all. So what union all does, it says, hey, take all the records from this first table, or this first query, and all the records from this second query, and combine them together. Now, if we ran this just as is, then we get a little bit of a funky query, but notice it says first name and last name, but yet we have admin and password and demo. But it put those records in that same query. So that does work. Now, even if we had an odd, a mismatch in columns, I could say something like this, where I'd say ID, username as first name, and password as last name. You might say, what's that doing, Tim? Well, if we run just this query, not both of them, we can see that if I zoom in here, now my column names are lining up with the person table, first name and last name, even though it's technically username and password are the two columns, but we're putting them into a different structure. So with this, even if I had, let's say, 3 or 4 or 5 columns in the secrets table, I could just say, yeah, but grab these and match them up, match their names up, and then add that to the previous query. Okay, so now we have that combined query results. So what does this mean for SQL injection? Well, SQL injection is where we're putting this value in this spot. Okay, so what we could do is we got to figure out what query could we write that you could put in this spot where the end result would be this query. Okay, so if we put it in this spot, first of all, the single quote would be the end. Okay, so that won't work, right? So it's just empty string, doesn't work, because it's looking for a last name that encompasses all of this. But how would we maybe make this different? Well, I could say Corey, right? And then I could put two quotes, right? And what two quotes does is it will say, actually I need three quotes, I believe. There you go, three quotes. So three quotes, I know it's kind of confusing. So three quotes says, actually I just want to put one quote here, but not make it, I want to exit the string, but I still want to have this one quote in the string, all right? Which, yes, it's a little confusing, but if you know SQL, you know now the rest of this stuff is available as a regular SQL statement, not as a string. But we do have this one single quote hanging out at the end. And if we run this, it's not going to run. It says that we've got a unclosed quotation mark after the character string empty, or looks like empty string. So we have to figure out how to fix this single quote. Well, there's another thing you can do in SQL, which is to comment something out. So for example, if I want to say this is a test query, notice it's all in green, and if I highlight this, if we just highlight just this part of it and run this would run. Whatever you highlight in SQL, by the way, it just runs just that part. So if I'm only highlighting part of it, it's just running that part as a query. It's both very awesome and very dangerous depending on how you use it. So, but this right here is a code comment. And how you do that? 2 dashes. So what could we pass in? We could pass 2 dashes. And now that last quote is actually just a code comment. Now if we run this, we will see that we get something like this, where we actually get just 2 records, the admin and the password. I'm not sure why I'm not getting Corey here. I probably messed something up. Not a problem though. We've demonstrated that we're actually running these 2 queries, or this query is one query. Well, how does this translate into our SQL injection? Well, we are doing this work, but in the front end. So let's look at how to fix that, right? So we're going to say, we're going to pass in Corey, right? And if you run that, we get Tim Corey. But I want to close out that quote. In fact, I think I spotted a problem here. Let's just stop it real quick. If I just do that, there we go. That's the solution, not 3, just 1. If we run this now, we'll get all 3. There we go. So that's what we're going to do. So we're going to do essentially mirror this query. And that's what hackers will do, is they'll try and mock up what this might look like, and then what could they do with that. So we're going to say Corey, and we know that there's a single quote at the beginning already and a single quote at the end. We have to take care of both of those. The one at the beginning, we can close out by putting a single quote after Corey. And then I can just say union all, select, we're just going to say star, from, and that's the secrets table. And I'm a good citizen and put the semicolon at the end, because semicolon denotes the end of a statement. And then I'll put my 2 dashes indicating we want to take care of that last single quote and close that out. So we're just going to comment that out because you don't need it anymore. So now when I do this and I search, notice I get my admin, password, demo, and demo for the other 2 rows. I get 3 rows of data, including 2 rows I should not have access to. I have just performed SQL injection because I trusted the user. I said, whatever you type in here is probably fine. And that's absolutely not true. Now you might say, well, Tim, how would they know that there is a secrets table? They might not. And if they don't know, what they can do is do queries on your master database to say, hey, what tables are there? And then do another call with whatever table they find. Or they could do other malicious things. I'm going to show you kind of the really fun one. This is, instead of, we're going to say we're going to put a semicolon at the end of this. So Corey, single quote, semicolon. Now I've ended my first query. I'm going to do a second query. I'm going to say drop table, demo table. And we do have a table called demo table, right? And I'm going to put my 2 dashes at the end to take care of that last single quote. Now here's the really insidious thing. If you search this, it comes back Tim Corey. It worked. The query worked, right? Yes, except for the fact that I have caused havoc in your database. Because if we close this out, we go back to SQL Server, there's demo table. Let's go ahead and hit refresh. And we come back to the tables, and demo table is no longer there. The table is gone because I dropped it, because I had access to do that. And this is why SQL injection is such a big problem. You can do all kinds of bad things and you might not even know. What gets even more insidious is sometimes what you can do is you can run commands blindly. Maybe you can't put the data back into this ID, first name, last name structure. Maybe you're not getting something like that back. That's okay. What you can do is run various commands that say, hey, when this happens, then I want you to put a pause in your return. And that way I know that that's actually a valid command. And then you just wait for your calls to go through, and when one of them has a pause, you know that one is the one that has the valid command. So there's a lot of things you can do blindly even in somebody else's SQL database that's a real problem, which is why SQL injection is such a big deal. So how do we fix this? Well, we have to go to our code, and we have to say bad, 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 don't do that bad. Okay, that's the first step. So for me personally, I do not like putting SQL directly in my C#. I like calling stored procedures. But even those you can have a problem with. We're going to see that in a minute. We'll just do it just in the SQL editor. But for now, let's fix the SQL call in our code. Again, I don't love it in my code because now you're modifying SQL in C# but you're trying to debug it in SQL, and I prefer to have it all in one spot where it's going to be easily debuggable. But let's fix this. So what I'll do is I'll comment out this first one, and I'll say string SQL equals select star from people where last name equals at last, let's do lowercase, at last name. Now, what is this? This is a query parameter. So when I pass in this results call, let's actually duplicate this. So Control D duplicates the line, and we'll comment out the previous one. And what we're going to do is pass in a parameter. So we're going to say new, and then we'll just do an anonymous class and say last name equals, and then we're going to pass in search box text.text. Okay, so we're passing in the search box text. Now I have not done any cleanup. I should definitely check that search box to make sure there's nothing funky going on. But even so, there's some things that are allowable. For example, O'Reilly would have a single quote in it potentially because it's got that dash, that single dash, and so or single quote. So therefore, you can't just say no single quotes. But even with that, you can do some things like maybe no horizontal dashes, because those can be used as code comments, and no semicolons, because why would you need a semicolon in a last name? Those kind of things can help with cleaning up that code. You definitely should do that. But you should also use parameters. So what's going to happen here is we're passing in a parameter list with the values. And then we have the SQL command that has a at, and then like this case, last name. That's a parameter. So it's going to take the value of search text and put it into at last name, kind of. Because if you notice, there's no single quotes here. I didn't single quote around this at last name. The way parameterization works is it's going to make sure that whatever you put into this text, it's only ever going to be treated as one text block. So it doesn't matter what you try to inject and comment out and all the rest, it's still going to treat it just as a text block. So therefore, it's going to be last name equals whatever you type into that box. There's not going to be a and something else at the end. So this is going to protect you against a lot of different types of SQL injection by just parameterizing your query. Now again, you should clean up that text first, but Just doing this is going to give you a lot of protection. Not all the protection, but a lot of protection. So again, pair both of those things together. Clean up that text box, don't allow certain things into the text box, and then also change this query. So let's run this again, and we're going to call that same injection attack. We'll make sure it works first. So Corey, and yes, Tim Corey returns. So we're going to do that same SQL injection attack. So we're going to say single quote, and then union all select star from secrets. I can't do the drop table because there's no table to drop anymore. It's gone. And then I'm going to do my code comment at the end, and I search that, and no results found. Why have no result been found? Because the search was for Corey union all select star from secrets code comment. So it's trying to do the whole thing, and it can't find anything because it's not actually allowing you to go outside of the last name field for your data. So that protects you against a lot of things. Now, again, I'm a big fan of worrying or taking this to the next level, which is using stored procedures. Let's talk about why, because there's a lot of misinformation and a lot of people are concerned about stored procedures or have heard, oh, they're so bad, they're so horrible, tons of business logic in the database is a bad thing. I don't disagree with that last one, but this is not business logic. This is a query, and query logic should be in the database because that's where the query logic runs and where you debug the query logic. So let's look at our safe and unsafe store procedures, and we'll call them. So here I have an unsafe store procedure. You pass in the last name, and then I declare a new variable called SQL where I build out a SQL statement. And then I'm going to print it for you so you can see what it looks like. We're going to execute that SQL statement. So what it's doing, it's getting in a parameter, but then it's building out a SQL statement from that parameter and then executing that overall SQL statement. That's a bad thing. Why are you doing this? Don't do this. You'll see this in store procedures though. Don't do this. So that's the bad way of doing things, but let's look at why. So we're going to say exec dbo.sp people _ unsafe, and we're going to pass in storm. Okay, and we're going to run this, and we get back. There we go. We get back SUStorm. So that works. Again, just because it works doesn't mean it's a good thing. We're going to put one more quote there. We're going to say union all and say select star from secrets. And then we're going to put our dash at the end and our single quote. Okay, and we're going to run this as well, and we get 3 records. Now, if we go over to messages and look at why, well, here's our statement. Select star from people where last name equals storm, union all select star from secrets. So that's our overall query. That's where I don't think I need to have that dash and the single quote at the end. In fact, let's just take a peek if taking that off works. Oh no, because I have to, that's what it is. I have to have that single quote at the end because of the fact that when in SQL, I have to have an opening quote and a closing quote. Therefore, I have to comment out that last one. So that's the unsafe SQL statement. Don't do that. So how do we resolve that? Well, you go to the safe statement. Select star from DBO people where last name equals just the parameter. And we're executing this. We're not doing the exe or the exec of the @SQL statement. We're just actually executing the SQL statement with the parameter. So if we go back to our statement here, we say safe. And let's just, for now, just run this part. So it's just execute the safe with just storm. Again, we're not executing the rest of it. We're just executing what's highlighted. And we get the SUStorm. Now, let's execute the whole thing. We execute this and we get No results. Why? Because it's looking for this whole thing as the last name. It doesn't care that there's code comments in there and there's an extra quote in there and there's an extra, SQL statement. Does not matter. It's saying, yeah, I'm just going to look for that as a last name. So therefore, it doesn't find that as a last name. Therefore, it doesn't execute. So that's SQL injection. That's why you need to be careful of it. That's why we do not trust the user. We do not just take text from a text box, for example, and put it into a SQL query. Don't build your SQL queries manually, which is a real danger here because a lot of people use Entity Framework, which can build the queries manually. And if you're not protecting what data comes in, you might end up with a badly built query. So don't do that. Make sure you sanitize this information and then make sure you use it as a parameter, not as part of a build a SQL statement, okay? That's very important that you kind of protect yourself against this. Now, I do want to say one more thing. Some people say, well, I'm not asking for data from the user, I'm getting data from the database. Therefore, it's okay to go ahead and do this kind of thing where I build out, because I'm taking the data from the database, not from the person. No, don't do that either, because you're still vulnerable to SQL injection. There are people who play the long game and will put information in a last name field, like that, union all, and or with a drop table or something like that, where it's basically a ticking time bomb. And it's going to be sitting there until you build out a SQL search statement with that data from the database. And if you haven't caught it, then what's going to happen is you're going to drop a table, you're going to change permissions, you're going to, change everybody's last name, you're going to do something destructive because there's a ticking time bomb in your data in your database that you may have missed. So don't trust data from the database either. Still do the parameterization. Always make sure you're using parameters whenever you're dealing with data so that you're protecting yourself against that bad data, while at the same time making sure you cleanse data whenever possible. Cleanse it when it's brought in. Check it when it comes to the database. Like, make sure that you're not trusting data at any step along the way. Otherwise, you're going to find out later that your application's been vulnerable for years and you just didn't know it. And so people might have been siphoning data out of your application and you just didn't know. You may have heard of data breaches where they went on for years. And you're like, how would they even happen? How did that happen? Well, something like this can be the reason why, because you've allowed something to happen where you don't even realize that when you return records, you're not returning just the a few that match the last name of Corey. You're matching the few that match the last name of Corey and all of your usernames or something of that nature. Now, here's a bonus tip, because so far we've talked about making sure we use parameters, and I've talked a bit about my preference of using stored procedures like this. And again, people might push back and say, well, that's bad because store procedures. That's not a good argument, okay? And this is not business logic. There's no business logic here. But even more than that, if you notice when I made the call to drop that table, so we had the table, demo table, and now demo table is gone because I did that drop table command as part of SQL injection. Well, another way to make yourself safer is to not give the user that's running these queries admin access. So if we look here under my connection string, by the way, warning, do not do this in a real app, store connection string in secret.json, etc. But if we look at, I use integrated security, which means whoever's logged in, which for this database, for these type of demo databases, is an admin user. Because we're using that admin user, I can do basically anything in my SQL database. I can query other databases. I can look for all of my logins for a database and find all the information about logins for the database. I can gather every table. I can download all the information I want. I can change tables. I can delete tables. I can rename things. I can whatever I want to do because I have admin access. And this is a very common thing to do because people get lazy. It works. And again, remember, you might have a front door in your house, but if it's just a framed out house and you have, just the studs up, well, you can walk in the side of the house. That's a problem. Okay, that's what it's like here, is that if you have admin access in your connection string, you've got a real problem because if anybody ever gets around your security, and again, I've shown you how to make your security a lot better, but it's not ever going to be perfect. So what you want to do is limit the damage they can do. And this is where I love stored procedures, because if I'm using all stored procedures for all of my calls, even if they are as simple as this one, something really simple. But even if it's that simple, then I use a stored procedure. And the reason why is because then in my connection string, I can use a user who only has permissions to execute stored procedures, or even better yet, only certain stored procedures. That's it. They can't list the tables. They cannot do a select star from a table. They cannot drop anything. They cannot modify anything. They cannot see users. They cannot do anything except execute stored procedures that I have told them they can have execute access to. What does that mean? It means that even if I allowed SQL injection, the very most they could do is the same thing that they could do with my application. So therefore, you're not nearly as vulnerable. Yes, you may have different permissions for different users and the same, connection string for all of them. Therefore, you could potentially elevate your permissions a bit, but it's nowhere near as dangerous as saying, hey, you can drop tables whenever you want. Okay, so there's a big deal difference, and that's where that bonus tip of using stored procedures allows you to lock down your database a lot more. Now, that is going to mean that if you are a fan of Entity Framework, you have to use stored procedures with it, because by default, Entity Framework needs to have admin permissions, or has admin permissions, because it not only reads data from your database and inserts data and deletes data, but it also creates tables, it modifies tables, it deletes tables, it creates other objects, it does a whole bunch of admin tasks. So therefore, you gotta do some work on Entity Framework in order to lock it down securely. Otherwise, that bonus tip doesn't apply to you. Okay? You can't lock it down if you don't do a lot of changes, because otherwise it just won't work. Okay, so that's SQL injection. That's how to prevent it. Yes, I know I showed you how to do SQL injection, but quite frankly, it's a pretty common attack vector, and it's pretty common knowledge how it works. My goal here is for you to understand it, so you understand what not to do and why you're doing what you're doing. You may be doing this and not understanding why. And if you don't understand why you're doing something, then you don't know why it's important to keep doing it. So make sure you understand that. Make sure you understand how to protect yourself and your database, because this is a big deal. This is the lifeblood of your application, of your company even. Because if any company loses their data or has their data breached, or worse yet, it gets destroyed, that can mean millions of dollars in damages. That can have long-term implications for the company, for the people that were affected in that database, and so on. You don't want to be the cause of that by sloppy programming. This is where you need to know, if you're trying to vibe code something, just because it works doesn't mean it's right. You've got to make sure that you're checking these things and being very careful to prevent things like this from slipping through the cracks. All right, so thanks for watching, and as always, I am Tim Corey.